Moonfall, a cinematic masterpiece, one of the most revolutionary films of the 21st century. One of many works of the absolute movie genius, Roland Emmerich. I'm not here to boast about the movie's greatness, as there's already multiple critics you can find on the movie. However, I am here to talk about the physics point of view of Moonfall. Where do I even start? I'll be showing you clips from Moonfall that really sums up the movie's logistics and physics.
Jimmy, hold my hand.
Come on, let's go! Let's go!
Jimmy! Hang on! Don't let go!
Now, I want you to find what's wrong with the scene I just showed. Yep, it was nothing. Roland Emmerich does no wrong. However, if I did had to find out a flaw, it would be the loss of common sense. Other than the fact that the snow and ground are not affected by the entire moon's gravity, for some reason, this particular wooden shed is immune to the moon's entire gravity. It's completely immune to the moon's gravitational pull, because when the characters go in the shed, the moon's gravitational pull doesn't affect them anymore. Obviously. I need a drink. I'll break down this scene for you. Let's start with the analysis of the movie. The concepts we're going to be using to analyze this particular scene is general physics, kinematics, Newton's law of motion, work, energy, power, all that basic stuff. So for some of the evidence, I was able to find the mass of the moon, which is 7.36 times 10 to the power of 22 kilograms, and then the gravity of the moon, which is 1.62 miles per second square, and the acceleration of the moon, which is 1.625 miles per second square. Then for the mass of the Earth, I was able to find 5.972 times 10 to the power of 24 kilograms. And then the mass of the tractor on that scene that was about to crush them for some reason is on average about 7,089 kilograms. And the mass of the actors, which in total resulted in 190 kilograms. And some of the missing variables that I wasn't able to find was the gravitational pull of the moon in this scene and the distance between the moon and the Earth in this particular scene. From these, we can find some questions to answer, such as how fast were the people running in order to escape the moon's gravitational pull? The force needed to pull Jimmy into the shed, which was the kid you saw in the movie. And how heavy must the shed be in order to sustain the moon's gravitational pull? The end questions I'm going to answer is the scene scientifically possible? And if it's not possible, how can it be made possible? Let's start with the calculations. First, we need to find the distance between the Earth and the moon in this scene. It's kind of hard since I cannot specifically find the actual distance, but I can estimate. So in this scene, you can see that the moon seems to be very close to the Earth's mountains, which I searched up in this movie is shot in Los Angeles. And from that, I can estimate that the average mountain in Los Angeles is around 93 meters. And because of that, the moon's distance is probably a little above the 93 meters mountain. So because of this, let's say that the distance is about 96 meters, just a little above the mountains. Because in another scene after this, or sometime after this, the moon did hit the mountain. Next, I'm going to be analyzing the gravitational pull of the moon in this scene. So the formula for the gravitational pull is F, which is force, equals the gravitational constant times the mass of the first object times the mass of the second object, and the mass of the first object and second object is divided by the distance between both objects. So here I was able to find that the gravitational constant is 1.62 meters per second square, which was converted into kilometer per hour squared, and then I found the mass of the first, and then the distance I'm going to use the 96 meters. But after some calculations and using the Desmos, I was able to find that the final, most simplified gravitational pull in the scene is 7.699 times 10 to the power of 46 newtons. So in this scene, the gravitational pull of the moon would be 7.699 times 10 to the power of 46 newtons. we're going to be analyzing the possible scenarios and the hypotheticals I've mentioned to see if the actual calculation result is physically possible. So how fast are the people running in order to escape the moon's gravitational pull? That's the first hypothetical. It's surprisingly quite difficult to outrun the moon's entire gravitational pull, since most people use a rocket, or at least some sort of space shuttle. However, let's explore the idea that these main characters can somehow outrun the entire moon's velocity. So for this, I just calculated the escape velocity of the moon, which the formula is the velocity is equal to the square root of 2 times gravitational constant times mass of the moon, divided by the radius. So from that, I was able to find the answer, which was 2.38 kilometers per second. Therefore, in order to escape the moon's velocity, the main characters have to run about, 2,380 miles per second. To put that into perspective, a normal human is only capable of running 19.3 miles per second. That's about 125 times a human is capable of running. You know, it's quite difficult to run that fast, right? It's quite a challenge to be able to run as fast as that. And you might argue with me and say, but this is dependent on how far the people are with the moon, therefore this calculation is inaccurate. That's not true. There were multiple cars in the scene that were shown to be pulled by the entire moon's gravity, right next to the main characters running. On to the next hypothetical. It's how many forces needed to pull Jimmy into the shed. In this scene, the amount of force needed will be dependent on how much the wooden shed's weight is. However, it can still be calculated by how much they need to pull based on the mass of everyone and the acceleration of the moon. So first, we needed to find the acceleration of the moon, which is about 0.052 kilometers per second. And then from that, we can use the force equals mass times acceleration, which is Newton's law, about 9.88 newtons, which is not that bad. It's physically possible. On to the final hypothetical. As mentioned, the moon's gravitational pull is roughly 7.699 times 10 to the power of 46 newtons. Using this evidence, we need to consider the mass of the wooden shed and the gravitational pull of the moon. So we can find the mass using the formula mass equals gravitational force divided by acceleration of gravity. But we need to find those two first. So the first estimation is the gravitational force, which is 7.699 times 10 to the power 46 newtons. And the second estimation would be acceleration of gravity, which we'll just use the Earth's gravity, which is 9.8 meters per second. So on to the actual calculation. How heavy must the wooden shed be in order to sustain the moon's gravitational pull? Use the moon's gravitational pull divided by Earth's gravity. Now I want you to guess how many kilograms it takes for the shed to not be affected by the moon's gravitational pull. Well, it's about 7,856 quattuordecillion. Hello, welcome to IKEA delivery service. Would you like an extension in your home's warranty subscription? No thank you, I'm actually here to order custom furniture. Of course, ma'am. What would you like? Yes, well, it's pretty simple. I only want a wooden shed that's not too small, not too large. I just want it to fit my tractor. Oh yeah, and I also want it to weigh about roughly 7,856 quattuordecillion. Ma'am, I'm not sure if I can do that. What do you mean you can't do that? I mean, it breaks the general laws of physics. The wooden shed you said will probably sink due to gravity. Plus, the materials that's going to need is quite absurd. Well, what else am I supposed to do if the moon's falling down and I need to protect myself from the moon's gravitational pull? How difficult is it for you to make a wooden shed? It's just wood! I just want it to weigh a few kilograms. What's wrong with that? Don't worry, guys. I'm pretty sure Roland Emmerich only forgot to put a scene where the main characters clearly had gravitational boots on that only activates when they're inside wooden sheds. He just lost the budget. In conclusion, we have explored the previous 3 possibilities, and it seems only the second hypothesis makes physical sense. However, the others did break, Newton's law of motion and gravity, considering their numbers were quite high. My final rating for the scene, as a Roland Emmerich movie, it's surprising how it only broke 2 laws in this one scene. I'd say it's an 8 out of 10 for a Roland Emmerich standard. But if I was talking as a physics perspective, I would rate it a 2 out of 10, considering it breaks multiple physics laws and, again, does not make any sense. Well, that's it for my analysis. I urge you to watch Moonfall if you're looking for the definition of a cinematic classic. When I arrived at the movie theater, there were about 12 people in the theater, and I left only seeing 5. That's all for me. Thanks for watching.